Good morning. Okay, so this is our today is our fifth lecture regarding naive Bayes rule. And so, as we discussed last meeting, next laboratory session we'll use that time for your long test one. Okay, so I am looking at that means long test one will be Thursday, starting at 12 o'clock. Okay, so 12 o'clock until 20 hours. If some of you still need more time, maybe we can go up to 3 hours. Okay, but we'll cover starting from the very beginning. That's uh, polynomial regression, and then decision trees and Bayes theorem. Okay, so that will be the coverage, and then the next for the long test two, it will be the next three topics. Okay, now is Bayes rule. Next will be neural network, and then support vector machine or support vector machine, then neural network. Okay, so we cover at least six topics in machine learning. Hopefully, you will be very familiar with it, and computationally. And what is important as what is the emphasis in this class is that you know the principles, the mathematical principles behind computational techniques in machine learning, rather than we use them to just for using and analyzing the results, more like a computer science type of work. So for us, we based more on we explore more on the mathematical principles. Okay, so let's share the screen. Okay, that's my screen, and we view presentation. Okay, so today is naive Bayes. So why is called naive? What do you mean by naive? In the Philippines, in Spanish, we call it naive. And even some of us have a surname Naive in my town called Mabini. It's Naive. What do you mean by naive? Huh? Mr. Imana, naive.
Sir?
When you say naive,
Naive.
yes.
Um, Neutral and unaffected.
What's that?
Neutral and unaffected.
Unaffected,
Neutral. Neutral,
natural,
yeah, neutral. Like pure. Yes, sir.
pure. Okay, yeah.
Yeah.
She's very naive like that. Yeah, you met a girl who's naive. It's not about natural. Well, maybe she's naturally shy. It's about shy, not very sure about herself. Yeah. So she's a little bit naive and innocent. That's why probably you say natural. Yeah. Naive normally is like innocent. Yeah. So yes, it's shy and not very sure about himself. So it is some kind of an approach on a Bayes theorem that is more of a direct approach or a shy approach. You know, you don't need to go Bayes theorem, have many terms, three terms that you need to compute. But for naive Bayes, it's a way to compute Bayes theorem directly. Okay, so let's consider first a review of all the techniques that we have discussed here. Okay, so for for polynomial, there were topics that we discussed. So there are three: polynomial regression, and then decision trees and Bayes rule. And so in all of these discussions, I want to emphasize that we really want to solve a function that gives us a relationship between the input and the output, such that the output will give us an idea on what kind of decision we'll be making. So for polynomial regression, we want a function that gives us a good estimate of the polynomial or of the data points that was given, so that somehow if we are given an input, we can roughly estimate where will be the output of that of the function. Okay, so in this graphically, for example, if the data, in this case the points, the data are given, So graphically, it looks like a sinusoidal function. I mean, the actual function is a sinusoid. If you can have a polynomial function that is similar to a sinusoidal behavior, then that function is a very close estimate of the data that is given. Okay, that was polynomial regression. Next is decision tree. In a decision tree, again, we are given inputs and we want to make a decision from that output, whether, for example, you want to play tennis or not, given that the inputs are the outlook, about humidity and wind. So all these characteristics will give us an idea of whether we are going to play tennis or not. Also, based on those features or parameters, we call them the input parameters, we will build a tree. Yeah. So that tree will help us decide. But then the question is, how do we build the tree? So the criteria or the criterion to help us build the tree or to choose which layer of the tree we will be using is the information gain. The information gain based on the particular attribute, for example, the XA attribute. So it is based on the entropy, the absolute entropy minus the entropy of of the expected output based given the attribute, yeah, the given XA. And so that is the information gain that is based on the entropy. Absolute entropy is given in this equation, and relative entropy or dependent entropy uh, is given in this equation, that is based on the attributes, the different types of attributes, plus and also that is a function of the attribute and the output given a particular attribute. Okay, that's the decision tree, and then we base those leaves and nodes and everything, the nodes and the layers and everything until we reach the leaves where you have the decision of whether, for example, to play tennis or not. Okay. Now the Bayes rule is based on conditional probability, that given inputs we can get the value of conditional entropy of a particular output given a certain condition. Okay, so it will give us a probability of whether certain things can be done or not. So it is for us to decide whether which probability we take. Okay, because something is a higher probability, then probably we'll take that. Okay, or we'll take something because there's least probability of failing, for example, is another way of looking at it. Okay, so the Bayes rule based on conditional probability is given in this example, in this equation, which of course this equation we can write in many several ways. So for example, the absolute probability of x, if x is composed of can be based on certain instance, then we can say that x given y and a probability of y, and so we sum all those x's based on we sum all the possible x's based on the possible y's. I mean, the x that was where the output is dependent on based on all the possible y's. Okay, so this is one possibility of writing the Bayes theorem, and the other way is if x is not dependent on any particular, if we are given the absolute probability of x, then we can use it directly. But if x, we are given only the dependency probability, then we write the equation. We write this. We use this other equation here. Okay, so many ways of doing Bayes rule. So now we look at a Bayes theorem. Okay, I mean a naive Bayes. Okay, so graphically, this is what naive Bayes is doing. So naive Bayes is about classification. Okay, so well, it's still about probabilities as well. It is based on on the Bayes theorem. Okay, so here, for example, if you have a naive Bayes classifier, so you have crocodiles and alligators. Okay, well, I don't know. Do you have crocodiles? Oh, you have crocodiles in Africa, yeah. But do you have alligators? Okay. Anyway, For us in the Philippines, we just have the same term, buaya. Is whether it's alligator or crocodile, just one term. Okay. But there in the US normally is alligator, bye alligator, see you later alligator, bye bye crocodile. So yeah, they use crocodile as something that is a little bit bigger and flatter, as you can see in these pictures. Those are crocodiles with uh, bigger mouth, but shorter elongation compared to the body. But for alligators, the mouth are much more elongated compared to the body, and they're smaller. Okay. So anyway, there's the mouth size and the body length. Okay. Based on these two parameters, you can group them together that these are the alligators. The relative, the mouth size are smaller and the body length are also smaller. Yeah. Basically, this is a smaller kind of crocodile. And the crocodile is bigger, okay? Much bigger. I mean, bigger mouth as well as bigger body length. Okay, so with this we can already see that this will be the group of alligators and these are the crocodiles. Okay, and so we can also plot in terms of the distribution of the sample, and so around here, so there's a Gaussian distribution of the histogram of the number of crocodiles, sample crocodiles based on these features that are given in terms of mouth size and body length. And so, excuse me. So we can look at it as two normal distributions of our sampling data. Okay, the red is the crocodile and the blue are the alligators. Okay, so now, so for example, we want to classify a new animal that we just found. Okay, so we don't know whether it's an alligator or a crocodile. It has a body length of 3 units. Okay, 3 units. What did we say here about body length? Okay, just the units that are given here, whatever these units. So the units, the body length of 3 units only. And so how do we classify it? Is it a crocodile or is it an alligator? Okay, so we look at the distribution features and then see whether we will decide it to be a crocodile being red, okay, or the alligator being blue. Okay, so that given more formally, we're given that the probability of a class CJ, given that we observe something about D. Okay, so D in this case, what is given to us is the length. Okay, so D is the length. It is the observed feature or the observed instance. Okay, so we observe that the length is 3 units, and then we don't know the classification. Where there are two types of classification, whether crocodile or alligator. So now, what is the probability that that animal is a crocodile given 3 units of length, or what is the probability that that animal is an alligator given that the unit length, the body length is 3 units? Okay, that's the problem that we are trying to solve. Okay, so if they given these two probability, I mean, given the two probabilities of alligator and crocodile, then we can immediately solve. Okay, so based on the data that is given, so the body length of 3 is here, and so we say that this is the histogram. Yeah, so the longer the histogram here, the bigger the longer the bar, the more number of population items in number of animals in that in this body length, yeah, in this particular characteristic. So so there number of I mean the number of animals in this yeah, in the body length. So now this is more and there's few and then there's lesser and lesser. So in the red, here are more and lesser on the sides. So now we say that here there are 10. Okay, there are 10, what is blue, alligators with a body length of 3. And there are only 2 crocodiles with a body length of 3. So given body length of 3, so here there are 10. 10 out of this is 12 because from the sample we have 12. So 10 out of 12, okay, it's an alligator. and 2 out of 12 is a crocodile. And so we say the probability is much higher in terms of an alligator. So because an alligator is smaller, yeah, 3 units. Let's just say not 3 meters, but 3 feet, maybe, yeah, 3 feet. So most likely that is an alligator. Okay, now if we choose it to be 7, yeah, we choose the body length to be 7. Now we take the probability of an alligator having a body length of 7 and probability of the crocodile having a body length of 7. So in this graph 7, so now there are more crocodiles compared to alligators. So in this case, crocodile is 9, alligator is 3. So now it means that most likely the animal is a crocodile because it's 7 feet long. Yeah, there are of course some animals, crocodile. I mean, alligators are 7 feet, but not too many. Yeah. So, for example, if you compare it to the height of an African, for example, versus an Asian, yeah, the height. So most likely, maybe let's say, for example, three. What is three? What is seven? Seven cannot be 7 feet. Okay, maybe it's 7 feet or yeah, okay, 7 feet African. Maybe that's rare. Yeah, but then 3 feet of, of a nation. Yeah, but somehow it's about the height. Yeah, the height African more a lot taller, and then lesser of an Asian that are beyond 6 feet. Yeah, something like that. So now, if you take, for example, 5 feet of an animal, whether a crocodile or alligator, so we see that in this case there are equal number of size. I mean, equal number of samples, and so in this case 6 and 6, and so there are equal probability of being. Oh, why is it? Why is this point 0.6? This is point 0.5. This is wrong. This is b point 0.5. One half. Yes, six. It should be 0.5. Okay. So that's wrong. I have to correct this so that when people see okay, that's zero point 0.5. When people see, I think it's my mistake when I was doing it today. Okay. So now it's 50-50 chances. We don't know. We are not very sure whether it's alligator or a crocodile. Okay. So next, it's about to end already on the, okay, annotation. We clear all drawings. Okay. So naive classifier is a visual intuition describing a simple Bayes classifier. Okay, so we can call it naive Bayes or simple Bayes or sometimes idiot Bayes. Okay, so when she's too shy, but then it doesn't say that when she's too shy, she's a, something else. She might be simple, but definitely she's not an idiot. Yeah, she's just being shy and natural. Okay, so while going through the math, we keep in mind that there are some unseen instances that we find the probability about it, given that is belonging to a certain class. In this case here, we don't know whether we can say that the animal that was given to us is a crocodile or an alligator, and we just take which one is most probable. Okay, please. Okay, who's that? Mr. Mukitsi. Mute. Okay. Okay. Excuse me. Ah, excuse me. Okay. So now let's connect to what we learned before. We learned about Bayes' theorem. Okay. So, sir, you ask me, sir, why is it now we don't go through all the process of all these computing? Last time we compute all these other parameters. Now we are given 3 meters, 3 feet of a length, and we want to see whether it's an alligator or a crocodile. Why are we just doing it directly now instead of computing on this one? Why? Do you have an answer? Why? So we say that probability of the CJ is, in this case here, we are saying that this is the crocodile or alligator. Yeah. And then now this is your length, body length. Okay, so we say body length. Why don't we say that this equation we can derive to be, let's just ignore that one. We say, why don't we compute the body length based on the class, whether alligator or alligator or crocodile. Okay, so probability multiplied by probability of alligator or crocodile divided by the probability of the body length. Why don't we do that? Why? And there are two classes of us. So how do we do this? CJ, there are two classes. And so if we look at the Bayes theorem that we just show here, so there are two classes of your possible output. Okay. That means that whatever is the output here, we say that it could be crocodile or alligator. And see, this is I index. Here, we are indexing it in terms of K. That means all the possible outputs, whether crocodile or alligator. That means that here, our equation will become here. So we can rewrite the equation based on the probability of that body given that it is crocodile times probability of a crocodile. What is the other probability? The other probability is that it is an alligator. Probability of body given alligator, probability of alligator. So why are we not doing this? Why are we directly computing this one? CJ. Okay, maybe instead of CJ, we can use C1. C1 given a body length. And so here we choose probability of the body length given C1. And C1 meaning crocodile, probability of C1. Okay, why are we not using this? So this one is the complete Bayes theorem. Why are we not using? Why are we just using directly from here as what we did here? So that is probability of C1 given the body length, and the other one is probability of C2 given body length. You see? Okay, C1 is this one. We can compute this one, many terms. Why are we not using this but just computing this directly? Anyone? Mr. Buaho. What do you think?
Yes, sir.
Yes, what do you think? Why?
Yes, sir.
We're taking shortcuts here, don't you think?
So you're taking shortcuts.
Yes, we are taking shortcuts. That's why it's a shy. It's not we don't go through all the strict Bayes theorem. It's a shy Bayes theorem.
So
Hmm.
isn't it because if we were to compute the probability of the body length, the possibilities of the length will be a lot compared to just two classes. There'll be a lot of classes of body length, like 5.2, 5.3, 5.1.
Hmm.
Wouldn't that wouldn't that take way too much computational power than just computing two classes, finding the probability of two classes?
Mm, not really. It's not dependent on that. What else? Any other guess? Who's this guy? Hey, One, you show yourself, not your roommate. Who else? Okay. Anyway, the time is running. So what we are saying here is that why not? Well, because we can given it is dependent on the data that is given. Well, if it is known, why not? We will use it. Okay. But if, for example, there's no way to compute this information, then we go through here. Maybe we're a given instance of, for example, what is the probability of the crocodile? The absolute probability of the crocodile. What do you need with that one? You need an entire data set to say how many are crocodiles and how many are alligators. Yes, we don't have that information.